Okay, I have pleasure to introduce the speaker of the day, Dr. Victoria Metcalf from New Zealand, the country of kiwis. We all know this New Zealand is country of kiwis, and that is what the indicator for the pollution. Okay, she is from the New Zealand Territory Education Commission, Principal Advisor of Vocational Education and Training. She is a scientist, science communicator, and also very active socially. Her description is given in the program which is given to us. But I would like to tell you something more about her. She is a good sports person. She do swimming, cycling, dancing, many things like that. Fellow of many academic and scientific organizations, number of organizations she works. She has a beautiful daughter. She is 12 years, 13, okay? She attended all the meetings, but this time she could not come. Okay, that is wonderful family she has. And I would like, and she is a very regular faculty to the Antarctica Commission, like those who go to Antarctica. She is a science teacher. She went on the trip to Antarctica as a faculty. And she took some of the pictures and her interpretation, science, Antarctica, and so and so. She gave the webinar to the Asia Pacific region on 30th March. And Tony was there. And he immediately said, we would like to invite Victoria for this keynote address. And I am happy she's here. She's also the country coordinator from Globe New Zealand. And also she the host for the next regional meeting of the Asia Pacific region in April. And I think you can invite all of them to come to New Zealand. So I give to Victoria and see some of the beautiful pictures of Antarctica. Thank you.
Thank you, Desh. I just want to work out positioning of the microphone. So can you hear me okay? Yeah, just sort of keep it here. All right, sing out if it's sound is an issue at all. So thank you so much, Tony, for inviting me to come and speak at this, and Simon. It's a great privilege to travel all the way from Aotearoa, New Zealand. I'm going to take you on a journey today. And in fact, the aim is like a journey and a journey within a journey, and maybe some other journeys as well. So it's a literal journey to Antarctica, as I did in January. So I'm going to talk you through that experience. But I want to take you also on a journey as to why Antarctica is important and why you should also consider it in the context of your globe activities. And I want to give some sort of generalised advice at the end of rules to live by, rules to do globe by, and to help create that sense of community here that we all have. So firstly, if you weren't at my the panel session I was at a couple of days ago, I'm just going to introduce myself. Ko aoraki te maunga, ko opawaho te awa no tauiwi ahau, no otatahi ahau, ko Metcalf toku whanau, ko Briani toku tamahine, ko Wikitoria toku ingawa, no reira, tēnā koutou, tēnā koutou, tēnā koutou katoa. Who here knows the All Blacks? A few of you, the New Zealand's national rugby team. Is anyone familiar with the New Zealand haka, which is done at the beginning of a rugby game? So it's a sort of a war dance. So if that's your familiarity, probably maybe with the Maori language, this is just giving you another side, that this is how we traditionally introduce ourselves in many spaces in New Zealand. talking about the mountain that means something to me, the river that means something to me, the city where I was born, and my family is my beautiful daughter, who can't be here and is very sad about that. I am not of Maori descent, and so I talk about how I am of the other people. So non-Maori, but I was still born in New Zealand. So these are my parents. My dad has sadly passed away. He was a horticulturalist and prolific writer of books about native New Zealand plants. And my mum was a pharmacist, so it was an incredibly scientific background. And actually, all my siblings and I have gone on to science or medicine kind of related careers. So it was quite formative. And because of what my dad did, I spent a lot of my childhood, along with my brother and sister, who are older than me, walking in the bush, often painfully slowly, stopping to look at plants for Dad, up in the mountains, scampering around rocky ledges and around lakes and rivers. But I also had a really great love of animals from a very early age. And quite early on, I discovered a love of the sea, fossicking along the seashore, peering in rock pools, trying to see what I could see. And yet when I went to university, it was biochemistry and genetics that captivated my interest, DNA, what lives in cells, what helps us make us what we are. And when I went on to do a PhD in biochemistry, it's then that slowly the marine side of things kicked in. And I was doing actually a PhD which was centred on tuatara, which, if you know them, are New Zealand's very unique reptile species that is not a lizard, not a dinosaur relative, it's its own thing. But along the way, one of my former lecturers heard what I was doing and sent a sample of Antarctic toothfish blood to me because he thought it might be interesting. And it did turn out to be interesting because the Antarctic blood sample didn't have the protein that I was studying. It was missing in these fish. And so I became absolutely fascinated by Antarctic fish. And I was very lucky to see a scholarship advertised in my local newspaper for a trip on a ship to Antarctica for a month. And I applied. Somehow, miraculously, I got it, and off to Antarctica I went for 1 month during my PhD on this ship here, that's the one on the right, and I actually got to see down there Antarctic toothfish in the flesh. That's the one on the left of the left photo, not the person on the right, but this is actually a small-sized Antarctic fish. This is only moderately big, so they can get much bigger than this. The trip down there was at times interesting, shall we say, and a bit nausea-inducing. But once we got down there, it was like an absolutely magical place. And this island is the first island that we came to. It's called Possession Island. It's in the Ross Sea, so this was travelling south from New Zealand. And it's home to a rather large Adelie penguin colony that you can smell from a very long way away. Really, really annihilates your nostrils. And this photo wasn't taken on that day. This was a few years later. But on that day, I climbed to the top of the same point on the island. I looked out, I could see the Transantarctic Mountains stretching as far as I could see. They're very, very large, like the Rockies, and surrounded by penguins and their smell. Curious around me, there were icebergs, blueness. It was just amazing. And I had this really life-changing moment there where I was like, this is what I want to do. I want to continue on with Antarctic marine studies. This was one of the friends. And I don't think the young people are back, but for anyone still youngish in the audience or young at heart, which is hopefully all of you, this is kind of how I looked for that entire trip. It was just like fizzing with excitement. And to be honest, that's probably how I looked all afternoon yesterday in the Mesa lab as well. I was still fizzing with excitement. So it was a really epiphanous moment for me. And so then, with a few ups and downs and segues into salmon sperm and back to Antarctic fish, I spent years researching Antarctic fish and shellfish and New Zealand fish and shellfish, and looking both at how things adapt to very extreme environments, but also what happens when you change the environment to simulate things like ocean acidification, climate change, impacts of pollution, etc. So known throughout that time as the nickname Ice Doctor. And then I kind of stepped away, partly related to the birth of my daughter. I didn't want to go down there for long periods of it at a time with a young baby, but also I was growing a love of science engagement and science communication. I stepped into another space, supporting schools, supporting education, and running a national platform for community-based science and technology projects. And this is also when I took on the country coordinator for Globe role as well. And so I had this really beautiful class of 11 to 12-year-olds of one of the projects that we funded, really amazing projects, decide that my job title of 17 words was too long, and that they came up with this job title of Queen of Curiosity for me. We've come from all around the world, right? We've travelled far to get here, and I'm from New Zealand, which, if you don't know where it is, it's about as far from we are as possible. There's some strange places that we've come from, maybe, including this very strange place here, Lorem Ipsum. I'm not sure where that is, or if anyone's from Lorem Ipsum. Put your hand up if you are. No. That's a design joke. But there's one space that's kind of missing on this diagram, and where no one really comes from, and that's this thing down here, which isn't even on the map. It's Antarctica, and that's what I want to focus on for the rest of this talk, and take you on this literal journey down there. So in January this year, I had the invitation to go back to Antarctica for a few weeks on this ship, a very large cruise ship, and to be an Antarctic expert and lecturer on board. So 1,900 guests, 700 crew, didn't get off the ship. So because it was so large, you could see things, but we never disembarked once we were in Antarctica. And it was just an enormous privilege to be there. A privilege for me, and an epic privilege for all of those guests on board. And it's this journey that I want to take you on, to show you what we saw and to tell you what I taught them about at the same time. So this is kind of the setup of what I was doing for some of my days. I worked extremely hard with the other lecturer and expert on board. We gave 6 lectures each, and each of those lectures for me took probably 20 hours or more of my time per lecture, because I went through tens of thousands of my photos to find the right images to talk about everything from penguins to fish to seabirds to whales to the food chain to climate change. And in the stage that I was speaking on here, the audience was 700 people for every single lecture, but it was also simulcast into 2 other spaces. So there were approximately 900 people watching every lecture I gave. And then when we were in Antarctica, it was all-day commentary from a site I'll show you on the next slide. So literally talking from 8 till, say, 4:35, mic'd up all day. And that was broadcast throughout the ship. You could listen in your cabin if you didn't want to come to where we were, and crew could also listen in their cabins as well. So here we are in action. For the first 4 days on the ship, no one knew who I was because I wasn't giving a lecture. And then after that, it just exploded. And we couldn't go anywhere without being stopped for questions, which was actually, it was hard work, but it was really awesome that people were that engaged. And for me, it was a real privilege that they would come to me with their questions. The commentary space that we operated in was up the front of the ship, and we had all the passengers around us that wanted to be there. So we were interacting with them the whole time. They could come to us with questions, we would answer them on the mic. We could also get tips from them. So say someone was on the right-hand side of the ship and they saw a whale, they'd call out to us and we could go over there if we were on the port side. So it worked really well. We were learning from the guests and what they were seeing, what interests them, what they were thinking about, just as much as they were learning from us. So it was very much learning in situ. And unlike most of what we do in Globe, this was primarily to an older audience, so adults. And a reminder that education, as we all know from Globe, doesn't have to take place in the classroom. It's really best when it's in the environment that you're talking about, and it doesn't always have to involve school students. So from the time that we first arrived in placement in the daily program, that's when the anonymity ceased, and it was a busy program with lots of activities, and we were ably supported by the crew on board. We got on in Buenos Aires and we got off in Punta Arenas. So now I want to share some of what I shared with the passengers with you about why Antarctica is so important and why we need to have that sort of global context when we're doing local work. So Antarctica, if you don't know it already, is a really pivotal continent. It actually is the health centre of our planet. Linked to Antarctica is most of our weather patterns, especially in the southern hemisphere, all the world's ocean currents, all of the world, sea level around the world, and all ecosystems in some way, shape or form can be linked back to the Antarctic food web. So it's incredibly important. The Southern Ocean is a unique ocean, which is actually the bottom part of the Indian, Pacific and Atlantic Ocean. It wraps around Antarctica and is actually geophysically separated from, or separates Antarctica from the rest of the globe. The thing that separated Antarctica was when South America pulled apart from the Antarctic Peninsula, and this happened about 25 to 50 million years ago. There's some debate over when exactly that happened. When those two land masses pulled apart, it created a current that goes around Antarctica called the Antarctic Circumpolar Current. We're used to thinking in Globe about water in the freshwater sense, the hydrosphere in a very different way, but this is a really massive beast. It's salt water. It's 24,000 kilometres long. It's the world's longest current. And the Southern Ocean is deep. The land mass of Antarctica is pressed down by the weight that sits on it of ice, so it depresses it. Coupled with the glaciers feeding into the sea and scratching out the bottom of the sea, it makes the ocean around Antarctica deeper than other continental masses, which is pretty cool, huh? It's also very cold down there, and I have been swimming a few times in the Antarctic waters, so I can say from observation and experience it's cold. On on average, right around the continent, not higher in the Antarctic Peninsula, it's minus 1.87 degrees Celsius. If you don't know, seawater freezes at minus 2.2, so it's hovering just above freezing, and it's very stable, so there's very little temperature variation, less than 2 degrees year round. And there's a lot of ice on the water in Antarctica. So both the atmosphere in Antarctica and the ocean around Antarctica we can think of as the motor that drives the planet. It's so important. So the Southern Ocean actually transports the biggest volume of water and connects all other oceans. Antarctica plays the most important part in the global distribution of not only heat, but also nutrients around the world. And the atmosphere, so the climate system around Antarctica, is also likewise a bit of a motor for global climate. So together, the climate and the water system, the Southern Ocean, are the heart and the ventilation or the lungs of the rest of the planet. And to show you the Southern Ocean and how that works is that around Antarctica, as I said, there's a lot of ice. When sea ice freezes, which happens in winter, it extrudes the salt as the freezing happens. That salty water that falls underneath the frozen ice is heavier and it drops down. And it creates what's known as Antarctic bottom water, which is the start of the motor that drives all ocean circulation. So that happens near the Antarctic continent. You get this cool flow, which then feeds in this conveyor belt into a series of cooling and warming around the globe. And when we mess with this, we mess with everything on the planet as a result. So you can see probably in some senses from a physical sense why Antarctica is quite a special place to study, but also from a biological sense, why is it relevant? And I love this quote from a book which says, however, while it's true that the geophysical and meteorological situations which Antarctica presents are unparalleled anywhere else, translation, there's lots of unique stuff happening there, and that its living organisms are remarkable in their successful adaptation to some of the most extreme conditions found on the planet, the things that live there are unique. The same scientific laws appear to operate in Antarctica as anywhere else. So what happens down there is as relevant as what happens here. So in terms of environment, size-wise, it's twice the size of Australia. Sorry, Australians. It's the driest place on Earth, so it's actually a desert. There's very, very little snowfall that actually occurs in Antarctica. In most places, it's 40 to 100 centimetres per year. But despite that, because of the cold and the stability of the cold, that stuff just stays and it's converted into ice. So on average, there's 2,160 metres of ice on the continent, and in many places is up to 4,000 metres, which is just a staggering fact. Only 2.4%, but growing unfortunately, of the continent is exposed or bare rock, so there is some of that. There's lots of frozen seas, ice shelves, which are culminations of many glaciers feeding directly from the land into the sea, and very cold temperatures. Minus 89 is the coldest temperature ever recorded on Earth down there, and very unique flora and fauna. So on this trip, this is where we went after leaving South America. You can see there were lots of circles, and we were mainly hovering around the top of the Antarctic Peninsula, never dropping below minus 60 degrees south. So what did we see there, and what did I teach the passengers? So firstly, on day one, we went to a place called Elephant Island. And if you're a history buff, you probably know the story of Ernest Shackleton and his men surviving there for many months after their ship got crushed in the ice. And this is what it looks like. So a privilege to go there. But the first thing that struck me, and that I was telling the passengers, is that there was very obvious glacial retreat. So most of the glaciers feeding straight into the sea, you could see they were narrower and there was a lot more exposed rock. It was recently exposed rock. There was also a lot of dust, which happens because it's quite windy in Antarctica. Volcanic often, or just scoria, so ground up dust from glacial action that blows onto the ice, and where it's there, it changes the albedo effect, which is the reflection of sun off ice, which keeps our planet cool, and it enhances melt. We were privileged, so that was the climate change side of things, so I could talk about that. But the cool thing in the biology space is that on that day, we were surrounded by hundreds of whales. And these were fin whales, the second largest mammal ever to have lived, bigger than the dinosaurs. And we saw them just doing a symphony of blows for an hour or so, which was just amazing. So whilst climate change was visible for the physical sense, you could see this is a noted return of biodiversity in this area since the cessation of whaling. On day two, we saw a lot of icebergs. So we're so used again, I think, in Globe to think about the hydrosphere in very different and small scale terms often. Here is the hydrosphere in a totally different realm. This is in the tip of the Weddell Sea. There are lots of mountains. We saw a research camp, but also we saw a lot of really big icebergs that had fed out from the glacial shelf, a very large mass of ice feeding from the land into the sea. And at times, stress fractures occur in that shelf and icebergs break off. And because it's from an ice shelf, the flat top of the iceberg is completely flat. So that's called a tabular iceberg. So for me, this was a real opportunity to talk about climate, about the different types of ice and the weathering of ice that occurs in Antarctica and the Arctic, of how glacial ice like this breaks down over many years into different forms. It's really fascinating and a really interesting part of the hydrosphere. And again, you can see that this is not the water you're used to studying in Globe. It's frozen. What happens is that the snowfall gets compressed over time. It turns into ice. It's weighted and compressed so much, many of the air bubbles get pressed out of it, and it forms very, very dense ice. A lot of weaknesses appear at the face of where the glacier is feeding into the sea, and periodically that'll just collapse. And as the icebergs weather, they will get moved by the ocean current, so they'll move around, but eventually they'll roll and get flipped. And then we start to see these beautiful sculpted, smoothed, ridged forms, which happen from sea action, until eventually they break down into little bergy bits here, and then smaller, and eventually they're just seawater, well, water dissolved in the seawater. So all of this ice that you're seeing here is fresh water frozen. Day 3 was pretty moody. It's often typically like this in Antarctica. It can be quite a cloudy place. So it's a good opportunity to talk a little bit about cloud types for the guests. And I think if we've got any cloud experts in the room, who can name this type of cloud? I think that the stratus clouds of some description, they're pretty low, but feel free to correct me. Often a very low ceiling of the clouds down there. You can see some dramatic mountains, seagulls or kelp gulls down there as well, the same species we actually get in New Zealand, which was quite bizarre to see that down there. And you can see how engaged the passengers on board were. And we had the most amazing experience that day, and it really, really engaged passengers. It certainly was a life highlight for me. I don't know if you've ever watched documentaries, maybe David Attenborough documentaries, where you've seen something called bubble net feeding by humpback whales. This is where the whales work together to form a circle of bubbles. So they're blowing bubbles, they're moving in a circle, they're sort of at different heights in the water, and the net of bubbles that's created traps the krill that they eat inside, and then they come up through the centre of that circle to feed on the krill. It's a very cooperative, very clever strategy, and it's effectively like using a tool, but it's using the ability to blow bubbles. And so we had this happen, 2 pods of 6 to 7 whales, one right off the starboard side and one just a little bit off the port side, both at the same time. You can see how close those whales were to the bow of the ship, and that the passengers were literally looking right down at them. It was amazing to watch something like that in situ. Such a great learning opportunity to see the biosphere in action. So hopefully this will play.
Oh my god. Oh my god. Oh my god. Oh my god.
It's not me, it's a passenger who gifted me this.
Ladies and gentlemen, if you look at
So that was gifted to me, that video, because I was actually commentating from the bridge, so I couldn't hear that noise. But of course, the passengers who were outside on the bow of the ship managed to hear the whales singing to each other all that time, which was incredible. And they actually recruited another whale that was on its own. It came in, it joined the circle, and it joined in the bubble net feeding. This was valuable too, to look at how we can identify things. And so a little bit like how we identify clouds, you can identify whales. And with these whales, you identify them by a few different things. It's by the bumps here, their hump here, and what's on their tail. So you can see in this photo, hopefully, that all their humps visible are slightly different in shape, and that's a way that we can differentiate them, along with the bumps on their snout, and also the pattern of barnacles on their tail also is an identification tool, as well as the pattern of whiteness underneath their tail and the extent of algae, sea algae growth that occurs underneath too. On this day, we were also lucky enough, it was like later in the season, near the end of Feb, to see the very beginning of winter. So winter forming, and that was through pancake ice formation. So I talked about glacial weathering and iceberg formation. This is now ice that grows on the sea, so it's from seawater, quite a different side of the hydrosphere, I guess. And so it starts as these little crystals underneath the water called frazzle ice, and then it starts to form like a sheen that's a bit greasy looking on the surface, which is called grease ice. And then once those start to come together, the crystals, it forms what's known as pancake ice, obviously named because it looks like pancakes. And these start to grow both in width and depth until they get bigger and bigger. And eventually they will join together and start to coalesce. And this is a process that sea ice forms every winter around Antarctica. And it forms a massive, massive band that actually doubles the size, the effective size of the continent. So think about how big that is. And in terms of a change, it's the biggest physical change, annual change that occurs on the planet, is the formation and the melting or retraction of the sea ice. The sea ice algae and the plankton bloom that's associated with that in summer is the biggest biological change, reduction and expansion on Earth as well. So we also saw penguins. Here's a raft, what we call a raft of Gen 2 penguins swimming together to escape predators and swimming quite fast. And you can see a little Gen 2 penguin popping in and out here. We also saw seals, such as Antarctic fur seals. And here's quite a good picture of some glacial ice. It's so compressed, it's blue in colour, and that's to do with light refraction. Day 4 was not grey skies. It was a very bluebird day if you're a skier. There were very dramatic mountains everywhere, and we went to a penguin island, or saw it, called Kuaville Island, which was pretty cool. Lots of interesting things to see, but more of that weathered glacial icebergs. And these lines here are from sea action underneath all of this, but the iceberg has now flipped up the other way. And you can see some early morning fog and these little caps, little hats of cloud, quite typical. Does anyone know what this cloud type is? No one's game. Come and see me afterwards. You can see these very dramatic mountains, steep sides, glaciation, and the ice in this case forms a cornice or an overhang on the top. This pink stuff is actually algae growing in the ice. Kind of crazy. In fact, all over Antarctica, buried in glacial ice, are many different bacteria and other microorganisms. Many of them have been there for thousands, hundreds of thousands of years, and they're still living. So this pink ice forms the ice algae around penguin colonies. So penguins make mess, they poo a lot, they vomit up krill, there's waste, and some of that dust blows onto surrounding ice. And in that dust, there's some of this algae, which then starts growing in the glacial ice. Now, this is predicted to be an increasing problem with climate change for exactly the reason I talked about before, is the ice in its nice form reflects light and contributes to global cooling. As soon as you put colour on ice, it starts absorbing sunlight, which leads to increased melt of that ice. So as we start to see more bare areas around Antarctica, and potentially with warmer climates, more of this growing, you're going to see an acceleration of melting, partly due to this formation. For those who put your hands up if you're a pedospherophile. I don't know if that's a word, but I just made it up. Okay, there's at least 3 of you and one not really fully willing to admit it over here. For the pedospherophiles, it kind of rolls off your tongue, try it. I like that you're giving it a go. It's really interesting down in Antarctica. So although there's lots of snow, there is some bare land, and particularly around penguin colonies or where it's a wee bit warmer, we see some interesting things. So firstly, there are some plants in Antarctica. There are some mosses and some lichens that grow. And this penguin island was actually really covered in both of them. But penguin colonies have their own soil. It's called orthogenous soil, so bird soil, and it's from thousands and thousands of years, typically, of penguins being in that colony, doing their business, and that slowly breaking down in some way or layering up into a very smelly soil, and that's what you see here. It's very interesting to study. There's people that study this. And that's the culprit, a Gen 2 penguin. You can see how they swim underwater. So we were lucky enough that day to see lots of massive icebergs. This one is quite a big iceberg. It's cathedraled, so it's had quite a lot of weathering. It's been around for a while, so icebergs can last for years. And we saw a lot of interesting mountains, and you can see that geological layering if you're a geology freak, which is really fascinating. And here you can see 2 cloud layers all in the one photo. We also that day saw a bunch of orca right around the ship, or killer whales, which was really special. If you ever want to know how to tell the difference between orca boys and girls, it's in the fin. So this is a female. She has a shorter, curved fin. And then a male would normally be big, pointier, much higher. This poor male, though, has had some kind of incident, I suspect with a ship, unfortunately, and it had a semi-detached fin, which is a bit unfortunate. There are 4 types of orca that live around Antarctica. And this was one of the subtypes. It was the Gerlache subspecies. And you can tell them by their patterns and also the colour. And you might be able to see that they have some algae growing on them here too. So that's a unique feature, particularly of this type of orca. So we had, again, very dramatic mountains on this day. This was day 5. Really famous landscapes. This is where a lot of the photos of Antarctica come from. We visited research bases. My daughter smiled, and we went past the world's southernmost post office at Port Fitzroy. Climate change, though, was on most people's minds. They'd been hearing a lot from me. They had a lot of questions about it. These guests on the main, the ones that weren't sitting with their back to the view or head down in a Kindle, were asking and concerned about climate change. And you can see how moss-covered that wee island is. So the interesting thing for me was going back to Palmer Station. Has anyone been there? No. This is a base I overwintered at when I was doing an NSF postdoc 22 years ago. And for me, it was really interesting to go back. It was very nostalgic to see the base and what it looked like now, slightly bigger. But freakily was when I compared it to my photographs from the time. These photos are from January, and this is from 22 years ago. It was midwinter, so there is a seasonal difference, which explains the snow on the ground. But perhaps you can see that the glacier here is a lot further back here. This point here is that point there. Okay, so you can see this level of retreat. And I think also when I look and compare, even on this side, it feels like it's pulled, it just feels less close to where the base is. So I was pretty shocked by that. And the passengers were hearing me commentate this in real time. So they were hearing my reaction, and they were getting this kind of visceral response from me around what I was seeing, and I could say about climate change. This was, I think, it's hard to tell what type of species of seal this is, but perhaps a leopard seal on an ice floe. With climate change, there's going to be less of that for them But you can also see in this photo the greasy nature of the sea, so it's close to freezing. And I just want to mention that it's such a privilege to come to Denver. Thank you for having me. One of the people that was on that trip with me 23 years ago, or 22 years ago, was Chuck Booton. Chuck Booton actually lives in Denver, Colorado, and he is this person here when we were fishing and trawling. And it was such a great thing to be able to see him after 22 years on Saturday and reminisce and look through his photo albums from this trip as well. So I got to tell the passengers all about my work, about Antarctic fish and how cool they are, how they have antifreeze all throughout their blood, which helps them survive that water, otherwise they would freeze to death, how we study them, how we fish for them, and some of the unique species that lack hemoglobin and red blood cells, so this is the colour of their blood, the ice fish. Pretty crazy to think that some vertebrates have blood that isn't red. And I really encouraged everyone to stay curious, which is always my motto for life. So the passengers learnt about me, they learnt about my adventures, but most importantly, they learnt about those 4 spheres that we know and love so well. So what were the learnings, and I guess what are the key messages for you around, apart from Antarctica's cool and important? I think guests were really grateful, and they frequently expressed that gratitude, and I was incredibly grateful for the privilege of being able to share my knowledge and my stuff in real time with them. Their engagement was through the roof. So we sometimes think, oh, you know, little kids are the only humans that can be really engaged. Well, adults can really engage with content too, and it was really cool to see that. And that photo on the right is some weathered down glacial ice, but you can see the different stripes in it which relate to different periods of climate activity. So the passengers had a huge thirst for knowledge. You can see how present they were outside, braving the cold at times. And I think that contextualised learning that we do in Globe and that we had here makes all the difference. What they also loved, and what I encourage you to always do, was the personal stories and the relevance. And I really loved on the panel the other day listening to my panellists with their personal stories as well. It really helped connect us all together, I think. Pitching things at the right level was so important for any audience. There were a few kids on board, including my daughter, and they all turned up to every single lecture. They were so engaged. There were crew who came and told me that they listened to every lecture in their cabin and that they listened to all-day commentary even when they weren't on duty, and that they were so grateful that they'd never learnt so much in all their lives. Didn't matter where I was going, what I was doing, I had people asking me questions. If it was 11 o'clock at night, 11:30, someone would come up and go, just one quick question, have you got time? And I always had time to answer them because those one-on-one chances of interaction are just so important for learning, even if they're silly questions. Now, something slightly silly for you is I do want you to repeat after me. Penguins and polar bears are never found together. People constantly confuse the animals at the poles, but they're really not. And when I tried to relay this message, I did it with humour, which is always a good tool to use, and say the only time that polar bears are found in Antarctica is when you see a polar bear-shaped iceberg, okay? But no, there's no penguin on it. The trip was also a real opportunity for me to show my culture and to share the Indigenous language of my country, New Zealand. So I used a lot of Maori, and to reference the fact we were travelling from South America and back to, I infused Spanish into every single lecture I gave and tried to teach them relevant words that they could use as well. And they really appreciated it. It was really good for me to stretch myself in that public space too. We've heard it throughout this meeting that you need to listen more than you speak most of the time. Sorry for talking so much today. And that it's really important to make anyone feel in the room. And I thank you so much, John and team, for that session on accessibility, to make anyone in the room feel included and have access to the information. Often when I was bouncing up and down and fizzing for joy, I would have guests come up to me and go, they're so cynical, some of these guests, they would go, are you just saying this is like you've never seen this before because you just want to make sure that we have a good experience and we go away feeling really special? And I would always say back to them, obviously you don't know me, because I don't make stuff up. I'm just me. I tell things as I see them. And I really wanted to reassure them that what they were seeing was often the first time I had seen that phenomenon, like all the whales or the bubble net feeding, etc., etc. And I was learning and just as excited as they were. So we needed to build a really good trust relationship. And I was constantly considering, am I conveying the right information? Am I being sensitive enough? What else can I say? What else do they need? So, to refresh your memory, Antarctica is that pivotal continent. All our weather systems, our ocean currents, our ecosystems, our sea level are linked to Antarctica. So don't forget that when you're doing your globe in your own place, that there's also this thing that your work relates to on a global level, and that what you do locally with Globe actually can end up having an impact on the health of our planet, the pulse of our planet, the lungs, the ventilation rate of our planet. When we got off the ship, I took my daughter to Torres del Paine National Park for a day trip. I last went there on my last trip to this region 22 years ago, and I really wanted to take her to Lago Grey. Who's been there? Anyone? Yay, a few people. Okay, this is what it looked like on that day. And I was just so disappointed, because 22 years ago, this is what it looked like. And it was just so marked that now there are no littering of massive icebergs all over the beach in front of you. And when I looked it up, the amount of glacial retreat in kilometres is massive. And the glacier, which you can see here, is would have been kind of here 22 years ago. That's sort of the comparison. So it's really pulled right back and probably shrunk across as well. So it was very shocking. What observations have you made, I guess, where you are about what you can see about climate change? Not long after we came back, and I had those kind of pictures of Palmer Station and Lago Grey in my head, there were these headlines telling me and telling us that that bottom water formation that I talked about, the heavy, dense water, that's declining really rapidly, much faster than the models were predicting. And that is going to rapidly affect ocean circulation and slow our global ocean currents down. It's going to impact on the biodiversity of everything living in the oceans, potentially around the planet. The lungs and pulse of our planet are changing very fast. So, why do we need to do what we do and keep doing it? Because science and technology is central to many of the problems we face. And our science literacy, especially of our young people, and using participatory approaches are fundamentally important to our future. On board, and this is kind of, a byline that I came up with, and Curious Science is all about empowering our communities for good, that they can do themselves. But when I was on the fly doing a recap lecture with my passengers on board, I said, you know, it's a few P's that come to mind. And they're relevant not only for what we were doing on board and for the passengers, but they're relevant for you all too. So it's a privilege that we have to be here and do what we do and to be on this earth. It's the place that we connect to. It's here, it's wherever you're from. It's the passion that we have and that we can instill in others to give a damn effectively and to make a change. And it's through that, hopefully, the protection of the things that we hold dear. So I suggest that people always think about this question of what do you value? So what are the things that are most important to you? Only you know that. And how can you use Globe to treasure and protect those things? And how can you and what you do in your daily lives think about global and local context together and how they interweave? My other rules to live by, and you will have heard me in the panel talk about that, is our networks and our relationships and coming together as a family here are just so important. You know, I'm so passionate about democratising science and the good that that does the world, the power that community science like Globe has to play. And there's a way to say that in Māori, which is he aha te mea nui o te ao, he tangata, he tangata, he tangata. What is the most important thing? It is the people, the people, the people. Final messages, make a difference. Any kind of difference, it doesn't matter what it is, but strive to do that. Never stop learning, stay curious. And just as you said, John Francis, be kind. Kindness really matters. I loved your talk this morning, by the way. So to wrap it up, and then I've got one more bonus slide I threw in just before. As man disappears from sight, the land remains. When we're not around, the land will still be here. But I guess what state do we want to leave it in? Whotu nā, naro, he tangata toi tū he whenua. And I know a few people have mentioned Sophia on this in the last few days. And I just, if you want to know some stuff about Sophia or what it was like, I was very fortunate enough to be a guest on a flight, overnight flight on NASA's Sophia telescope plane, which is about observing the universe in deep space. Now retired, but this was in Christchurch a few years ago. So happy to share that. Here are my contact details. If you want to watch something really embarrassing about me in Antarctica that's quite old, you can. I don't know if it works outside of New Zealand, maybe it does. You can watch this documentary for 1 hour on the right, which shows me in action. It's very embarrassing. And it's actually filmed with our former Prime Minister, Jacinda Ardern's fiancé. So, any questions?
Thank you, Victoria. That was fantastic. We're all, saying, wow, all these cool animals. I'm curious about the signs of human presence that you've seen in Antarctica, in both types of trips you've taken. We are in Antarctica, we're studying the place. What impact are we having from afar and from within? Thank you.
Ooh, that one's louder. Great question. So I did some research to look at the impact of, or the presence of PBDEs in Antarctic waters and in Antarctic fish quite a few years ago. These are compounds that arise from building materials, and they were prevalent in Antarctic fish, especially near the research base McMurdo Station, and they were at sufficient levels to cause potential reproductive harm, which is a bit concerning. We know now that there are microplastics in the air and in the water in Antarctica, so on the snow, on the ice, and floating around the atmosphere. That's been studied by a former colleague of mine. Visibly, you know, bases have an impact, but they try and really restrict the impact, and they're always improving their processes and protocols. And some of the rebuild of bases, like Scott Base, which is our base in the Ross Sea, and McMurdo Station, which is the biggest station on the ice and has up to 2,000 people living there over summer. So it's like a little city, little town. Some of the rebuild is around reducing environmental footprint, much more sustainability. So there's a wind farm, Generation 2 wind farm is going down there. There's extensive wastewater protocols to treat the waste. If you're in the field, your fecal material has to get flown back. If you're in New Zealand territories to New Zealand, it cannot be dealt with on the ice. So yeah, there's constant attempts, but obviously there is an environmental impact of having a presence down there, but we can only hope that the needed presence there to study things outweighs the impact.
You said that polar bears and penguins are never found together. I can tell you where you can find them together. San Diego Zoo.
I knew someone was going to bring that up, but I'm talking about in their natural habitat. So, but thank you for pointing that out. You are in fact correct.
Joking aside, has there been an attempt to find out if a den of polar bears can thrive on Antarctica, and if a family of penguins could thrive in the north?
No one's done that research, and nor would we try from a biodiversity and a biosecurity perspective, but it's one of my most asked questions that people ask me. Are they, you know, we all worry about polar bears, right, and their fate, because they rely on the presence of sea ice to survive, and with that diminishing rapidly, you know, should we transplant them all to Antarctica? No, we should not. We're just going to have to find other ways to hopefully preserve polar bears in their natural habitat.
Thank you.
Good question, though.
Maybe time for one more, if... Yep, Rod?
Yeah, you mentioned early in the slides that Antarctica is the heart and lung of the planet. So my question is very simple. Who takes care of Antarctica, and who is responsible for conserving and protecting it?
What a great question, and I didn't talk about that at all, Rod, so I'm pleased you brought it up. So Antarctica is a continent that's devoted to peace and science, those two activities, nothing else. So no resource extraction. And the thing that protects Antarctica is called the Antarctic Treaty, which from memory 12 nations, including New Zealand and the US, signed in the 1950s. And that treaty holds for 50 years. It can't be the 1950s, later than that. So when it expires, hopefully it will get refreshed. There's a lot of additional signatories to that treaty down there. So no one owns, whilst there are territorial claims in place for Antarctica, under the treaty, none are recognised. So all the treaty signatories, in essence, have a duty to care for Antarctica. And there are so many protocols and processes around that. Great question.
Wonderful. Well, I'd just like to say thank you so much. And maybe we can just all appreciate Victoria's amazing talk. Thank you.